Good afternoon, friends. Welcome back to Parijat sir classes. So after a long time, I have again uploaded. I'm going to upload one more chapter, which is very important chapter for the JEE mains. So I hope you will be benefiting from this chapter because this is a very important chapter regarding the JEE. So I've got a lot of requests for uploading this chapter as a gist. So what I'm going to do today is that I have made the whole of the magnetic effects of current chapter, which is one of the most important chapter, into a single presentation of the board. The whole chapter has been gisted into a single board, and I can guarantee you that if you could follow what I am going to teach today, this will be not taught by anybody else. So if you follow what I am teaching you, this is going to cover the whole magnetic effects of current, including the derivations. I have written them in very short. If possible for you, those who are following the class, if they can take a snapshot of this, because I will be referring to this and explaining it. So the chapter is magnetic effects of current, and I will be slowly dealing through all the topics which is there. So let's get started with this without wasting time. And I presume that when you are listening to my lecture, you are also noting down certain important things and facts about what I am teaching. So let's get started with this. Okay. So magnetic effect of current, it's got a lot of weightage in the mains. There are a lot of conceptual questions being asked from this section, a lot of numericals come, and a lot of diagrams and a little bit of derivations are also expected from this particular chapter. So without wasting any time, let's get started with this. Okay. So the first topic is a charge moving through an electric field. So watch what I am teaching here. There is an electric field. Watch the direction of the electric field. The direction of the electric field is shown along the y-axis. The direction of the electric field is shown along the y-axis. That means the electric field moves like this. Suppose there is a charge Q passing along the horizontal direction along the x-axis. So this is the electric field, and the charge Q is passing in a horizontal direction along the x-axis. Suppose at a particular time it covers a distance x. It is covering a distance x. So what is happening when the charge is entering inside the electric field? It gets a force. It is getting a force. What is the force? F equal to Q into E. This already you have studied in the electrostatics chapter. So there is a force acting along the electric field on the charge, which is F equal to Q into E. Now if there is a constant force acting on a charge we all know should have a mass. So if a charge is getting a force, that means there will be an acceleration produced along the y-axis. So what is the acceleration? Acceleration will be force by mass, which is QE by M. So this acceleration will act along the y-axis, which will make the charge move vertically up as it is covering through the electric field. And as it is passing through the electric field, it will experience a force due to which it will move like this. So there is a displacement of the charge along the y-axis. But there will be no displacement along the x-axis because force is acting along the y-axis. Okay. So this is the acceleration which is produced on the charge. Now, no acceleration. The charge will have a constant velocity along the x-axis. That means there will be acceleration will be 0 along the x-axis. So how much time? That means it is moving with a constant velocity. So let the velocity be v. So what is the time taken to cover this distance? It will be x by v. Now we know that if there is a displacement, according to the formula, if the displacement is y, ut plus half at square, this formula, if I apply it, what is the velocity initial along the y-axis? 0. Because Initial velocity was along the x-axis. So initial velocity along the y-axis was 0. So if I apply here, then what are we getting? We are getting only half at square. In place of a, if I put this value, x square by v square. So keeping all the values constant together, and the y, let us take it as a constant, which is k. So we are getting x square equal to ky, and this represents a parabolic path. So we can easily understand then that when a charge is moving along the electric field, it is getting a force along the y-axis. And when it gets a force along the y-axis, it is covering a path which is a parabolic path. Okay? So, along the electric field, as you can see, that the charge is covering a parabolic path, and the acceleration along the x-axis is a constant acceleration. Acceleration along the x-axis will be a constant acceleration, and acceleration along the y-axis. So this acceleration will be 0, and this acceleration will be QE by m. I hope you understood. So due to which it will cover a displacement, y, and the equation was given x square equal to ky. Now this is a parabolic equation. This represents a parabolic equation. So we can easily tell that when a charge is moving along the electric field, it will always show a parabolic equation. I hope this is covered within a very small part, and this is a very, very important derivation of ISC. It is a very important derivation of ISC. Lot of short questions come from here. Second part we move is if the charge is moving along the magnetic field. Now here we will represent the magnetic field as B, electric field as E. Okay, we represent the electric field as E and the magnetic field as B. So what will happen if the charge is moving along the magnetic field? So let's watch it. This is the magnetic field arrow. As you can see that the arrow is shown, this is the magnetic field B. So this is the magnetic field, and we are projecting a charge with a velocity v, which is making an angle theta with the direction of the magnetic field. We are projecting a particle q with a velocity v, which is making an angle theta with the magnetic field. So this velocity v will have two components. One is v cos theta along this horizontal direction, and one is a v sin theta, which is perpendicular direction. So this is v sin theta. So as we know, applying Fleming's left hand rule, we know that in the left hand rule, if we know the motion, the direction of the magnetic field, the motion of the charge which gives the current, the charge is moving like this, so the force will act on the charge which will be perpendicular to the plane containing the magnetic field and the velocity. The force will be perpendicular to the plane containing the magnetic field and the velocity. So a force will act on the charge. A force will try to act on the charge, which will be making the charge move up, which will make the charge move up. So what is actually happening? See, the particle follows a helical path. How will the particle move? Like this. The particle will follow a helical path. That means it is covering a circular path along with a shift. It is covering a circular path along with a shift. Because there is a force up, so it will take the particle up. So when a particle moves up, it covers a distance as well as a circular path. So we know that in a circular path there is a centripetal force which acts. So the force which will act on the particle, the force acting on the particle of charge q moving with the velocity v at an angle theta, the perpendicular component is v sin theta. So this is v sin theta, this is the magnetic field, and this is the force. So what force will act on it? It is F equal to q v sin theta into b, q into v sin theta, q into v sin theta into b. And we know v sin theta and b, according to vectors, they are cross products. So I can write it as F equal to Q V cross B. That means the force is actually perpendicular to both the velocity and the magnetic field. Right? So we are applying here Fleming's left hand rule, basically. So now watch friends, what is happening here. As the particle gets the force, what is the force? It is QVB sin theta. The particle moves in a circular path. So there is a centripetal force. So let us find out. We know centripetal force is what? mv square by r. M into v square by r. What is r? R is the radius of the circle it covers. So the centripetal force will be mv square by r. And we know that when it is covering a circular path of radius r, this is radius r, magnetic field is like this, into the paper. Magnetic field is into the paper. The velocity is this. Magnetic field is into the paper. So velocity has to be perpendicular to it. And if the velocity is perpendicular to it, the force should be perpendicular to both the magnetic field and the velocity. So this force will make it tend act towards the center of the circle. The force will be actually acting towards the center of the circle. So what will be the force? That force is the centripetal force, which makes the particle move in a circular path. So what is this force? mv square by r, where v is the velocity of the particle, r is the radius of the particle, m is the mass of the charge. And we know that when the velocity is perpendicular to the magnetic field, when the velocity perpendicular to the magnetic field, the angle is theta is 90 degree. So applying here sine 90, which is 1, we are getting the force as F equal to QVB. So F is equal to QVB and F is also the centripetal force. From there, we are getting the velocity as BQR by M. BQR by M. Now B, Q and M, these are constant for a particular particle. So radius will be variable. So more the radius, more the velocity. And we know angular velocity is V by R. Angular velocity is actually V by R. So putting the value of V here, RR will cut. So we are getting the angular velocity as BQ by M. So angular velocity of the charge moving in a circular path is actually what? BQ. This is the angular velocity. BQ by M. Now we know angular velocity is 2 pi by t. 2 pi by t. So from there we can find the time period of rotation of the particle in the circular path. We can find the time period of rotation of the charged particle around the circular path. So how much it is coming? It is coming 2 pi m by dq. So in this way we can see that when a charged particle is actually passing through the magnetic field, it obeys a circular path. And we can find out the time period required to cover one circle in a circular path. So in an electric field, how was it obeying? It was following a parabolic path. In a magnetic field, how is it following? It is following a circular path. Clear? So did you get the difference here? So we can easily estimate from here that the particle is moving in an electric field in a parabolic path. In a magnetic field, it is moving in a circular path. So a lot of questions come from here about finding the time period, about finding the velocity. So they give you the direction of the charged particle, and based on that, they ask you a lot of questions. That they can give you the direction of the particle along with the magnetic field. Angle will be given to you. You will be asked to find out the radius. You will be asked to find out the direction of the charged particle. So let us see the next topic, which is the Lorentz force. It's a very, very important force. Lorentz force. Lorentz force is what? It is a combination of the magnetic field and the electric field. The condition, we first dealt with only electric field. Then we dealt with only magnetic field. And now we are dealing with the electric and magnetic field both together. So in that case, what is going to happen? That force which will be created due to the action of both electric and magnetic field is the Lorentz force. So in the Lorentz force, the net force will be F electric field, F magnetic field. For the electric field it was QE. For the magnetic field it was BQB. Considering sine theta, theta is 90 degrees, so it is BQV. So basically, if I combine these two forces, the net forces acting on the charged particle under the electric and the magnetic field will be F equal to Q E plus V cross B. This is the net force acting is the Lorentz force. Okay? Sometimes they ask you expression for the Lorentz force. Next we come to cyclotron. It is one of the most important topic which comes for the ISC. Now, in the JEE mains or in the advanced, what they do is that they make a numerical which is in the combination, a little bit of cyclotron part included, they make a numerical. So you have to really understand the concept of this. What is a cyclotron? A cyclotron is a device in which you can make a charged particle gain velocity up to a maximum level. You can make a charged particle move constantly like this and gain velocity. Okay, so ultimately the main use of the cyclotron is to accelerate a charged particle. So how we do that? Placing it in a magnetic field. So what's the cyclotron? I have done it in a very short because this is only the required thing. You don't need it in very details because if you know this, it's more than enough. You can cover up any numericals. See, this is the magnet, North Pole and South Pole. This is North Pole, this is South Pole. So magnetic field is moving like this. Okay, magnetic field is moving like this. Now here, there are two half discs, half disc, which is hollow from inside, half cut disc D shape, which is hollow from inside. They face like this. They are facing like this with a gap between them. Let the radius of each disc be D. Now, what is connected to this disc is an oscillator. Oscillator. What is the function of the oscillator? It oscillates the connection. This positive, this negative, then this positive, this negative, this positive, this negative. So the charge, that means the polarity of the two half D's which are there, they are constantly interchanging the polarity. Their positions are not changing, but the polarities are changing. Plus, minus, plus, positive, negative, like this. Okay? So if I consider this, suppose there is a proton here. Initially, the disk D1 is made negative. The disk D1 is made negative. So this proton gets attracted to the D1. The proton gets attracted to the disk D1. So as it gets attracted, it is moving under the magnetic field. As it gets attracted, there is a magnetic field, there is a velocity by the proton, so a force will start to act again on the proton. And this force, I told you, will make the proton, in a magnetic field, I told you, the proton will cover a circular path. So the proton starts to cover a semicircular path before it comes out again. The proton will try to cover a radius r before it comes out again. So basically it is covering a path of how much? Pi r, not 2 pi r. 2 pi r by 2, pi r. It covers the distance of pi r before it comes out. The moment it comes out in the gap, the polarity interchanges. Now D2 becomes negative and D1 becomes positive. So the proton gets attracted to the disk 2. And when it gets attracted to the disk 2, again under the effect of the magnetic field, it again covers a half circle. And again comes out. And when it again comes out in the gap, again D1 becomes negative. So again it attracts. So this continues. This process continues. And slowly, the proton starts to cover a larger velocity, a larger radius basically. It starts to cover a larger radius, and we know that it has to come to this gap at the same interval of time. So if you are covering a larger radius and has to reach at the same time, your velocity has to be increased. If you are covering a larger distance but have to reach in the same time, that means your velocity has to be increased. So as the proton covers half of distances more increasing radius, its velocity has to increase. So what is happening? It constantly gains velocity and then ultimately comes out. You can see the charged particle is coming out from here. We can see that the charged particle is coming out from here, Q. So this comes out with the maximum velocity, V0. Now see what happens. So what under the magnetic field, what was the force acting? BQV. And it is covering a circular path, so it will have a centripetal force mv square by r. So from there, what did I find out? R, mv by bq. So this is the radius of the path which is covered by the proton. So now what happens? The time period it is covering is 2 pi r. 2 pi r. So what is the time period? Time is the distance by velocity. So the distance is 2 pi r. It is pi r and pi r. So 2 pi r by velocity. What is the velocity? Velocity is given as this one. From there we can find out the velocity. So we are putting 2 pi r by v. So from there we can find out what is the time period required. See, if I cut v and v, so from here I can get what is the v here. If I cut v and v, so mv by r equal to bq, so v will be bqr by n, which I have put it here. So rr will cut, r and r will cut, so time period is coming 2 pi m by bq, and these values are a constant. That means it has to cover every time a circle and come in the gap at the same time. So it has to maintain a constant time. That is why its velocity should increase. Okay? So basically, taking every time the same time, every time it is covering a circular path, half of path, it will take the same time. So its velocity goes on increasing, and when it comes out, it has the maximum velocity. And let that maximum velocity be V0. Let that maximum velocity be V0. So we can write mv0 square by r0. Centripetal force was mv0 square by r0 should be bq v0. The maximum centripetal